Hi, welcome to DragonCon. This is the Harry Potter fan fiction session, so if you're in the wrong room, you need to move out. I actually did that at the EFF track at DragonCon, and a couple of people looked at themselves and said, they're like, I'm in the wrong room. I'm Keith Watson. I'm the Information Security Manager at the College of Computing. I'm also the sponsor for Grey Hat, which is the Georgia Tech College of Computing student organization for information security, which participates in capturing flags all over the world. And I also moderate the DC 404 mail list, which pretty much consists of banning JD's posts. But other than that, it's pretty straightforward. And I do a whole lot of hacking and all manner of things, this being one of my fun ones to do. And that's all because of my wife, Loretta, here, who's with me. She's very understanding, gives me lots of time to do lots of hacking. She's totally awesome. So you can thank her for all the evil that I'm doing up here. Right? So I'm going to talk about NarkNet, or passive Wi-Fi surveillance. Now, what's interesting about this is people will go, what's Wi-Fi for surveillance? Well, we're going to talk about that. And we're going to talk about what kind of information you can hear doing this type of surveillance. I'll discuss the legalities of it if you want to try this on your own. It is quite simple to do. There's nothing magic here. You don't need any uber hacking skills. How many of you have ever downloaded an ISO and burned it to CD or DVD? Okay, congratulations, you have all the requisite skills to do what I'm about to demonstrate. And we are going to do a live demonstration. I will give you some legal warnings of what happens potentially when you do this, how to stay out of hot water if you do it, and also why this is becoming a growing issue. For a long time it was kind of becoming less of an issue. Now it's coming back to being a really big issue, actually. How to protect yourself and where to get more information. Wi-Fi surveillance is very simple. It's basically listening to Wi-Fi communications and collecting information, but doing it in a manner that you're usually not typically expecting to do. More often than not, we either associate with an access point and do some type of active attack. We're not going to do any of that. This is a completely undetectable attack. You cannot detect attack. Typical wireless attacks using active methods of things like man-in-the-middle, hard-cache, poisoning, evil twin. If you're actually paying attention, you can see these attacks happening, and that gives you away. Now, my background is systems intelligence for the Navy, cryptography. We use techniques like this. The idea is you don't want to be detected. If I'm right up on top of the enemy, if they find out I'm there, we die. They are very unforgiving. They decide, oh, we are going to have an unscheduled weapons test. So that's a bad thing. So the idea is you want to do this in a manner that's undetectable. They don't know you're there. If they don't know you're there, they're not trying to feed you false information. If they do know you're there, they're also not out looking for you. Okay? So we're going to use those types of techniques and ideas. And this came to me because most of the people who do any type of Wi-Fi interception like this usually try to sniff the backbone, meaning they put a tap on the uplink of the router or on the backbone of the network, and they analyze the data that way. We do this right out in the air, which is really kind of cool. And you can do all the channels at once, which is really also awesome. We're going to actually have a live demo set up. I got to finish setting it up today over in the room next door. We're going to actually capture all the traffic around us and show you what we find. I'm waiting for the day I go and do one of these demos and don't find anything. That would be pretty awesome. That means y'all are doing your job. Yeah, exactly. What can you hear? Basically, if it's web encrypted, even WPA for crack the key, web if we have the key, crack the key, or unencrypted, you can listen to the traffic. Okay? This is on any device, laptops, cell phones, tablets, anything that's using Wi-Fi whatsoever. That means all your emails, social media, all your accounts, your web traffic, your login credentials, your cookies, whatever, including voice over IP calls. Now, where that comes in handy, which we'll get into later, is what's happening with these guys that threatens your voice over IP and actually takes it out of the realm of needing a warrant to not needing a warrant. That means they can legally capture your phone call conversation, not the metadata, the actual conversation without a warrant. So, is it legal? Yes, and sort of no. The Wiretap Act says it's not illegal. There's an exception for any public broadcast. That means if you broadcast anything on an unlicensed or an unregulated band, there are some bands that are regulated and you require a license to transmit or receive on those bands. Those are protected bands, so even though it's unencrypted, intercepting traffic is a crime. Wi-Fi, however, is on a band that is not protected. Everybody assumes it is, but it's not. The court cases, however, disagree. There was this little company you might have heard of called Google. They got in hot water with their Street View cars. They decided that to improve the accuracy, have you turned GPS on in your Android lately? And it says, do you want to, JD would never turn on his GPS because he doesn't want to know where it is, right? So, I can have it back. There's no movies.
I didn't say anything.
Yeah, you gave me the book. So, you turn on GPS and it says, would you like to improve accuracy by turning this whole thing on Wi-Fi? And what they did is they drove around as they mapped things. They kept track of all the access points they saw and their relative signal strength based on where they were on GPS. Now, why that's important is, how many of you run an access point at home or at work? When's the last time you moved its physical location to a different address?
MAC or SSID?
The MAC address. The MAC address. Quite often they stay there. They might move from one end of the house or to another room, but geographically they don't move around all that much until we started using these for access points. However, they can tell from the MAC address who the manufacturer is. They know it's a phone, they just disregard that information. But the idea is by using that information, they can say, oh, I can hear these other people around me with these relative signal strengths, and the satellite says I'm there, and with all this information, they get a much more accurate location. Yeah.
Just to clarify, a portion of a MAC address, a legal MAC address, is a manufacturer code. Are you saying that just based on the MAC address, the first couple of
octets,
yeah, octets in there, some of those are manufacturer code. There are other ones that are for test purposes, are reserved.
Yes, yes. It's kind of like IP addresses, similar to that.
So if they find a MAC address that says it's a cell phone, then it's okay to just go ahead and wiretap?
No, not at all. We'll get to that later. No, it's that if they're using Wi-Fi access points to help improve geographic location information, if I see a Wi-Fi access point while I'm mapping and street mapping with my car, and it happens to be somewhere in this vicinity, it's probably not going to show up in Atlanta next week. However, if it's a MAC address for a manufacturer of the chipset used in phones, then it could show up in Atlanta next week, so I'm going to ignore anything from that particular chipset. Okay, so they do things like that. Now, it came as a great mystery to Google that when they hired the guy who writes NetStumbler to write the code to capture all the information about the Wi-Fi stuff, that it was actually doing full PCAP captures, they seemed to be surprised by this. Okay, so what happened was they got taken to court for violating the wiretap law because they did full PCAP captures. They said they weren't using the information, but they captured all that. Now, when's the last time any of you have actually used a Wi-Fi access on your laptop or cell phone? All of you have, recently, right? When you turn your laptop or phone on and say, show me all the access points in the area, guess what your phone or your device is doing in the background? It tunes to a channel. It says, tell me everything you hear. It pulls in all those packets. Wait a minute, isn't that what Google did? It sifts through the packets and says, oh, that's an access point? Isn't that what Google did? Yeah, and then it gives you a list of them. That's pretty much what Google did. But they kept the full packet captures. Well, when you do this, you don't. The court did not quite understand this, and so a federal district judge ruled against Google, saying they had violated the wiretap law. Now, his justification for this, despite the fact that the long-standing ruling is that public broadcasts of unencrypted data over an unlicensed or unregulated band is considered public information. You can receive it, it's yours. The person who transmitted it has no control of it. Much like if you're walking down the hallway and somebody walks past you talking to someone else and you overhear their conversation, there's no right to privacy. Same thing, right? Well, they ruled against Google. Google appealed it. during the appeals process, that was in 2011, in 2012, the FCC ruled on this particular issue and said Google did not violate the Wiretap Act, that this falls under the Wiretap Act exclusion for public broadcast. Now, part of the way that the judge had ruled that public broadcast, that this was in fact illegal, was he defined public broadcast as broadcast by the public. That means some government organization. Because one of the examples they give is things like fire and police radio. Because those are, now they encrypt them, but it used to be you could use a shortwave radio and 2 minutes in, and it was legal to do so. Just like you do air traffic control, you can listen to that legally. Well, he said, no, broadcast by the public. That means it's completely, according to his ruling, illegal to listen to this access point, which is owned by someone who's in the public, a public person, but that's not broadcast by the public, which is the government. So you can legally, according to him, listen to the traffic if it's broadcast by a fire station or a police department, just not your neighbor. Well, the FCC said, no, that's not right. Now, they did turn around and fine Google $25,000, but it had nothing to do with wiretap. It had to do with they impeded the investigation, so it was for impeding a federal investigation. They fined them $25,000. Now, on top of that, the FCC ruled on that, and then another case came up where a company providing services, what it does is it actually looks at the traffic, much like Google looks at all your traffic on their site, looks at the traffic, and based on that does some stuff, and it's doing this with wireless networking directly, and it sends the data on. And it's part of their service. You actually sign up for this as a service, their vendor. And they got ruled that they were charged with violating the Wiretap Act. This next federal judge said, no, that's not a violation of the Wiretap Act. And he goes back to this 2011 ruling. This 2 federal judges warring here says, no, that in fact was not a violation, and he proceeds to tear this other guy's analysis to shreds and goes back to the original understanding of the FCC and says, no, clearly not wiretap, but this is a separate case. So now there's 2 cases, and by the way, there's a bunch of people waiting in the wings to sue Google over this, based on what the ruling is. So now you have one court says it is against the law, the FCC saying it's not, another federal court saying it's not, and Google says, what are we supposed to do? You're going to let people sue us over something you all even can't agree on. So they went to the Supreme Court of the United States and said, could you please rule on this and determine whether this is legal or not, or it's wiretap or not? And the Supreme Court declined to hear the case. That happened in June. So as it stands right now, it may or may not be illegal federally, depending on which circuit of the United States you happen to do it in.
So who says it's legal? Is that California?
You'd have to follow, if you, by the way, if you go to any of these blue things here in the presentation, which you get, it takes you to the actual case, and you can look at it. I don't think it was a California court that ruled it was illegal.
That was illegal. So that's East Texas probably.
Say what?
So that's probably East Texas that says it's illegal?
No, I actually think it's middle the U.S., northern, like Illinois or something. I think. I think it is Illinois. So that means it's kind of a quandary. You're not sure. So if you want to experiment with this, I would highly recommend you do it on your own stuff. There is a potential for getting in hot water when you do this. And it all depends on what jurisdiction you're in and what happens when you do it. And if anybody complains. Now, did I mention it's passive? It's undetectable that you are doing it. But if they see a big 12-foot projector screen of it, it's kind of obvious, right? Now, we're going to actually do a live demonstration of how this technique works. Now, this is completely off the shelf. I'm using Kali Linux, which is a pen testing build. The only reason I'm using it, it's a very handy build. It's kept current. It's got all the tools. Everything's built in. I can get it as an ISO, boot it from USB, boot it from CD, boot it off the net. It runs on darn near anything. I probably run it on a toaster. It's great. Like I said, we can passively, there's web traffic included. It's completely undetectable. I'll show you here that the light is not even on my wireless adapter. And you can do the analysis live, or you can do full PCAP captures, or both, do them simultaneously, and analyze the traffic later for whatever you want to do. I mean, it's full PCAP captures. Everybody here is familiar with PCAP, correct? I assume? More or less. Okay. When you capture packet data, there's a standard format called PCAP that most of the tools use that will actually captures the full contents of the Ethernet packets and records them to disk in a standard format. And then you can use any tool that understands PCAP format to then pull the data back in and analyze it, or even do replays if you want to actually retransmit the information on another network and then watch what the network does. That's what they commonly do when you have some kind of malware that does something interesting. You have PCAPs running in the background, and you go, what was that? And you can go back and replay it and see what the software did. Pretty handy. Now, one of the problems you have with most modern versions of Linux is there's this little tool called Network Manager, and it tries to do everything for you. And unfortunately, it will get in a tug of war with what we're going to try to do with the network interface, and it says, no, that's my interface. I go, no, I got it. And it says, no, that's my interface. So one of the ways you handle that is you tell Network Manager, please leave this alone, okay? And the simple way to do that is you go in and edit the interfaces file, and you set the interface to manual. And as you can see, these are the commands right here to set it to manual. And we're going to create some other interfaces. We're going to create a scan 0, a mod 0, and an AT 0. You can create multiples of those, have them predefined in your configuration. Those names, the WLAN interface, your actual network interface, that you can't do anything about. That the system gives it that name. But these other names are completely arbitrary. I use scan 0, mod 0, AT 0 just to keep track of who's talking to whom when I do these demonstrations. Once you're done, you will need to reboot your machine. It is possible to start and stop services, but with Network Manager and some of the other services, they're a little twitchy, and the easiest thing is just make the changes and reboot and you're done. So, we're going to be using the IP and IW commands. Most of you are probably familiar with ifconfig, IWconfig. Those have been long deprecated, but most people don't know that. Yes. So all the really cool features are in IP and IW. All the cool kids are using those. And since you're the cool class, because you're obviously here, right? You're going to start using these commands too. There's, if you go to NarkNet.com, there's actually a link to a bunch of information about IP and IW if you're not familiar with it. There is a website about this called NarkNet.com, by the way. Now, what we're going to do is we're going to create a scan interface and a monitor interface on the same adapter at the same time. You can actually create multiple interfaces for the same adapter. They can even run simultaneously. However, when you do that, it's your wireless adapter is kind of like spinning plates. While it's scanning, it cannot be receiving data in monitor mode. So if somebody's doing a high-speed transmission, you're going to miss some data. So the best thing to do is put it in scan mode, do your scan, turn that off, then put it in monitor mode, use your monitor stuff, or have more than one adapter. We have one that's doing scanning in the background, looking for devices, and then you pass that data off to something else if you want to do that. Yeah.
Is there specific Wi-Fi hardware that works better or not at all?
Yes. He asked, for those at home, he asked if there's better hardware for doing this. The answer is yes. In fact, the write-up that I sent to PhreakNIC for this topic actually listed the hardware I use. If anybody wants to talk to me afterwards, I can get into some of the details about the chipsets if you're really into that, because there's the newer hardware, the N and AC hardware, does MIMO and multiple streams. And that means you can actually miss parts of conversations if your adapter can't do multiple streams. And the number of streams available in the actual standards, no one's actually building hardware that does 4 streams in either N or AC. But yeah, I have, in fact, if you want to talk to me afterwards, I'll show you the adapters I use. The one I use is by EDI.
What was the difference between scan and monitor?
Scan is very similar, which I'll demonstrate. It's very similar to what you do when you take your laptop or device and say, show me all the access points. Well, this is manual. It's actually going to return all the information after it parses all the data it hears. It will actually give me all the technical details about them as opposed to just a list of names. It'll even show me ones that are not broadcasting an SSID, which I can capture those too. That's kind of like having a radio station that just doesn't broadcast its call sign. You can still hear what he's saying. He's broadcasting data, right? Once we bring up the monitor interface, we bring up the scan interface, we do a scan, we find our target, we then bring down the interface. We're going to be interested in the MAC address of the access point that we're targeting, and we're going to want to know what channel he's on. Okay. Then we bring down the monitor interface, the scan interface, we bring up the monitor interface, we set the channel to our target. We then have a little bit of a problem. As you see down here in the bottom where it says monitor, and then it goes to airtime, and it goes to AT0, and over to the left it says radio tap header, and on the right it says Ethernet header. All the tools that you typically use for analyzing data know how to deal with Ethernet packets. Imagine if you took a raw Ethernet packet, which can come in out of order, right, the signal, and you handed all that data to your email program, raw. It would kind of look at you like you're an idiot, right? Or it might kill over dead, give you a buffer overflow on your Windows box. But the idea is, when we transmit packets over our Ethernet network or wired network, you have to have some type of information to tell the hardware what to do with the actual packets and how to reassemble and do things with them and route them. That's what the Ethernet header does. Well, there's an equivalent header for the radio communications called the radio tap header. So you now have the Ethernet packet in its header with another header stuck on the top called the radio tap header. And coming out of the monitor interface we're going to create is the packets with the radio tap header intact. That's a bit of a problem because all the tools we use only understand Ethernet headers or Ethernet packets, which means if you take the raw output out of the non-zero interface, give you tools, it's going to look at you like you've lost your mind. So the best way to do it is strip off the radio tap header and put it on the wire. Now, your access point and your wireless card do that as part of their stack. When it comes out the ports on the back, the network ports on the back of your router, the radio tap header has been removed. The way you do that manually is part of the AirCrack suite, which most of you probably heard of, that's what you use to crack web. There's a tool called AirTun for virtual tunnel, for air tunnels, and it will strip off the radio tap header. Part of the data you get it is the MAC address of the device you're interested in. By giving it the MAC address of the access point, I will get the access point and its clients because the MAC address is in both the send and to field, the from and to. So regardless of who's transmitting the packet, I'll get all the packets. And then we can analyze them. And they will come out the AT0 interface. I point my tools at that, and presto, we're now analyzing traffic in real time, completely passively. So basically, it's like taking your radio and tuning it to a channel and simply listening to what you hear. And all you need to do this is download the Kali Linux CD and boot it with a wireless card. Probably the one you already own. Okay, we'll do it. Now, okay, let's do a live demo here. So. Okay, home on my own badge. What happened to my probably. Hello. Oh. There we go. Okay. Now, what I'm going to do here is we bring up a prop. And, well, first off, let me show you, we do an IP link. This is going to show you my adapter, and you see we have a WLAN 0. Can you read that okay? Okay, we have a WLAN 0. This is an alpha, by the way. This, as a G receiver only, if you're not doing the N, this is probably one of the best hacking receivers on the market. Everybody who does anything in hacking, these are about, you asked how much this is. This is about $29. When you buy them, you get a kit with a high beam antenna. This also supports an external antenna, which is real handy if you want to make a CAN antenna or any type of directional antenna. If you just have a regular USB adapter, which, for instance, the Rosewell and the EDI Max I use that are N adapters, those are just regular USB adapters. So for directionality, since they don't have an external antenna, I just stick them at the focal point of your typical dish antenna, which you can get free by the curve, right? Those give you roughly about 18 dB a gain, which is really good. So you can see we have the WLAN 0 interface. What we're going to do first is we're going to go in and create our scan 0 and mon 0 interfaces. Okay, so if I do an IP link again, now you see we have a mon 0 here and a scan 0 interface assigned to and attached to the WLAN 0. We're now going to bring up the interface, the scan 0 interface, and then we're going to actually do a scan. Now what I'm going to do is I'm going to pipe this to less. Now, this is actually showing us everything it saw. As you can see, typically you'll have the MAC address, the wireless MAC address, the BSSID, if it's broadcasting one, will be right here. Oh, look, there's the PhreakNIC, the open access. We have an access point now for PhreakNIC. I set that up a little while ago. Thanks to Scott, who brought us his WiMAX base station, which allows us to get nice connectivity here. Otherwise, they charge us the craziest things of money. Thank you, Scott. Scott, by the way, is the director of the EFF track at DragonCon, where they've been into all kinds of topics like this. If you haven't been, it's really awesome.
If you want to speak next year, see me again. All right.
Yeah. So now this is interesting. The SSID for this one is unhackable NSA surveillance game. Somebody has a sense of humor. Okay. So what we do is, if I go here and look, and this happens to be the MAC address I'm interested in. That's my actual access point here. So if we search for that, there's my access point. Oh, there's the first one, of course. Why does it say free? That's very interesting if they have the same MAC address. They do. They have the exact same MAC address. This is this access point. His SSID is NarkNet. There's his MAC address. That is the right one, right? 984C. Yeah, they have the same MAC address. That's interesting. And we noticed also he's on channel 11. That's the other bit of information. If there were any other capabilities of this particular router, not that they're using them, but it tells you the capabilities. As you notice this one here, this one has N capability. It's got all these extra information here. It tells you everything you ever wanted to know about these routers. This is what your device is doing in the background. It just typically doesn't show you this information. We're doing it manually, however. Now, so the next thing we're going to do is we're going to take down our scan interface. And then we're going to bring up our monitor 0 interface, and we're going to set it to channel 11. So the first command there brought up the interface. The second one sets it to channel 11. And now we're going to create a tunnel, and we're going to use that MAC address that we're interested in, and it's on channel 11. Oop. It's dark up here. Okay. I need my backlit keyboard is what I need. There we go. Now, that's created our AT0 interface. So if I bring up another terminal here, you now see we have the AT0 interface. So we've got the monitor interface, feeding airtime. Out of airtime is now Ethernet packets. They would be coming out of this AT0 interface. Now we have to do something with these packets, right? So let's give it to a tool. So one of the things you'll find is a lot of the tools expect an interface to actually have an IP address. So we're going to assign it an IP address, but we're going to give it an IP address that's non-routable. This ensures that we can't accidentally transmit any packets or leak any information, right? And it's an address that isn't going to be used by any other device. Now, at this point, we bring up that AT0 interface. That interface is now ready to point tools at. We can point Wireshark at it. By the way, Wireshark knows how to read radio tap headers natively. We could point it right at the non-zero interface. But if you save out the PCAP and then try to analyze it with something else later that doesn't recognize radio tap headers, you won't be able to read the data. Okay, so we're going to use a tool called EtterCap. Now, these command lines, this TZQU means, hey, turn on, don't do any ARP cache poisoning, just do a basic filter using standard ASCII and use the interface AT0. That's what those commands mean, because we're not trying to do a man-in-the-middle attack or anything else. So I'm now going to run that. Now, EtterCap is now listening to that traffic. So if any traffic were being transmitted on channel 11 between this client and this guy, we would see it. So, we're going to go plug back into here. Now what I'm going to do, come back in here. What I'm going to do, if we get, yeah, that's working. Oh, and I want to duplicate, sorry. Good, we're duplicating. Now, what we're going to do is I'm going to go here, and there's NarkNet. That's our access point. I'm going to associate with him. Now, this guy is unassociated. Now, if you notice, that little green light is not blinking. This is not actively transmitting anything. For those in the cheap seats, you'll need a telescope. This little green light here is not flashing. So that means nobody can hear what we're doing. So I've now associated with that access point, and what I'm going to do, I'm going to do what people normally do though when they're messing with them. Normally you would do this from the wired side. I'm going to go and log in. Oh yeah, that's definitely not right. Maybe there's that. That's our login prompt. So if I were to type, hello world here, that's not a valid password, obviously. And send that. I just transmitted that information in clear text over the wire. Now that should have worked. And it didn't. Okay. No? Now why not? Anybody know?
Because you're live.
Because I'm live, that's right. I did not pay obeisance to the demo guys. They are punishing me. So, no, the reason is because there are times you get, there we go. So, where the system misses information. You are going to lose information. It's not absolutely perfect. If we were doing this for real, for actual systems intelligence, we'd build dedicated hardware. It wouldn't miss anything. But this is off-the-shelf, cheap seat stuff. Instead of spending millions of dollars, you're going to spend about 30 in a CD. So now let's see if we capture any data. Sure enough, we captured our data. As you can see here, we have our test, and here's the last one I put in, which was hello PhreakNIC. Now, this would be normally dumped to a text file. This is just text. And you would route this to a text file and save for later. I'm just doing it to the screen, so once I click this, I lose all this data, right? Well, one of the ways you can, that's real handy for doing this, let's say you have multiple instances. Now remember, we're receiving everything on channel 2. What if you have, yes?
I noticed whenever you were typing it, you made a couple of typos and you immediately backspaced over them and then typed again, but they're not in your capture file. Is that because it only sends whenever you hit character return?
Yeah, when you hit character return and you actually submit the data, that's when your browser actually does a submit. And that's when the data actually goes out across the wire and you capture the data. While you're typing in the window, it's not. Now, if you were doing telnet, on the other hand, that every time you type a character, it goes out to the wire, comes back and echoes to your screen.
And if you hold Control or Alt,
it's going to see all of it. Yeah.
Or if you're using Ajax JavaScript for the logins, you would see that live too. But
Now,
on the web form.
Now you notice we're seeing a bunch of other stuff here. We're going to see DNS requests. You'll see things like guys that go out and say, hey, where's that? I have a printer assigned on this guy that, you know how you go in and define printers? Well, they're in the background constantly going, hey, the printer's online, can I get SMTP? Guess what it does when it asks for SMTP data? It sends the password and user ID in clear text, and it'll happily capture it. So you get all kinds of very interesting information here. Now, we're only receiving channel 11, right? And we're looking at this one access point. But we're receiving on the monitor interface every access point and client within earshot of the receiving range of this guy is actually being intercepted. We're only filtering out the stuff to this access point and its clients. So I can create additional tunnels for every other access point that's out there. We can literally intercept everything on channel 11 that we can hear. Yes?
One more clarification. Where it says user, it just scrolled off screen, but was that text the same as what was in your GUI that asked you? I mean, how did that know user and pass? Why was it?
Because it's doing, it knows the protocols. This happens to be what's called the HTTP auth protocol, and there's a standard format for how it sends the data. It then peels it apart and actually gives it the thing, gives it the label user and password. If you were to see this on a bunch of other stuff, you'd see where it say protocol being used. See where this over here, it says HTTP right here? That means it was the HTTP auth protocol, and the user was this, the password was this, and this was the IP address that this other machine was talking to, or the machine it intercepted from was talking to. So if this were, for instance, a login to a POP account, you would see POP3 over on the left, and then over here you'd see this right here, it'd say POP3, and over here it'd say user, or user, password, and the site and URL, or the ID of the site he's actually talking to. It would actually show you that. It's really, really kind of cool. Now, this is just a text file. If you have multiple ones of these running, obviously you're trying to have multiple instances of EtherCap all talk to the same log file. They would go in, you'd get a collision, they'd write over the top of each other. So the simple solution for that is you have them write to syslog. Syslog queues everything up in a queue, writes it to a single log. That's what we're going to be doing next door. So you can actually capture as many access points, all of the channels simultaneously, all the access points you can hear, you can capture simultaneously. And then I mentioned it for a $29 adapter and a CD, you can do this. Now, don't you feel safe? Okay. So let's continue here.
That was in a different language, would it still be user pass?
Yes, it would still be user and password. Now, that demo I did recently at a hacker event called Interrupt in Atlanta, and I wasn't planning on giving a demonstration. I was kind of had a booth where I had this running in a passive mode. I wasn't actually intercepting, I was just showing some data I'd collected and showing some stuff for DC404 and also for College of Computing. And the booth was so popular that people at Interrupt asked me if I would do a closing presentation, do a live demo. I said, sure. So we set this up like you see right here. And they very quickly realized that by posting carefully to the user ID and password field, when it displayed on the screen, they could display ASCII art.
Cool.
Yeah, it was pretty awesome. When they did that, I was like, wow, I've done this at lots of cons. I've never had anybody do that before. That's pretty awesome. Okay. There we go. Okay. We're good to go here. Now, you can use lots of tools to filter through this, such as EtherCap. Firesheep's another one. You've probably heard of that for sidejacking. Firesheep has kind of gone the way that Dodo burned. It's no longer being supported. They're no longer developing. It runs on very old versions of Firefox. It has to have plugins that know how to specifically read the cookie. So if they even change anything such as a variable name, it will stop working. So I was looking for something that does a much better job of doing sidejacking. And I found a tool called Cookie Cadger. Cookie Cadger also has this very unique ability. Firefox, once you shut the browser off, everything you've captured is gone. There's no way to record anything. Cookie Cadger, on the other hand, will write to a SQL database. So you can have multiple instances writing to a database and have another one uses for an analysis engine. That's what we're going to do next door when we set this up. And since it's captured offline, you can analyze the data later. You can also, if you're doing full PCAPs, do replay attacks and analyze it again later. So there's all kinds of fun things. And Cookie Cadger is a Java file, or a Java application, comes as a jar file. It runs on everything. It's really, really awesome program. A grad student did it as part of his thesis, I believe. So that's what I'm using now is Cookie Cadger for sidejacking, EtherCap for capturing this stuff. There are lots and lots of other tools. I do this as a demo to explain the rest of the slide because the hard part is convincing people they need to do something. Now these are the legal warnings. If you do this, you can get in some serious trouble. If you actually access any of the resources using the captured credential, that's a crime, unless it's your account or you have the permission of the account owner. So if you ever do this at a conference, or any place for that matter, do not use the credentials to log in. I'm going to get tired of baking you cookies in federal prison. Besides, they're not going to let you read them anyway. They'll give them to the guards. Now, some of the laws that you're going to violate, since I'm at Georgia Tech and do these talks there, the computer network and usage policy for Georgia Tech is a violation of that policy. The Georgia Tech Honor Code and the Board of Regents policy is also a violation of those. To do these demonstrations on campus, I have to get special dispensation from the Pope of Information Security. It's also a violation of the Georgia Computer Systems Protection Act if you use the credentials. The actual capturing the data is not illegal. It's when you use the credentials. That's kind of like if I find a credit card on the sidewalk up front and I pick it up, put it in my pocket, that's not a crime. Charging stuff with it is a crime. Okay? Well, also the Computer Fraud and Abuse Act, the Communications Privacy Act, and potentially, depending where you happen to live and the time of day and whether the judge has got a bad haircut, you may find you're in trouble with the Wiretap Act. Now, why is this so important? Because there's been this trend You notice this cool look? Wow, I'm way out of sync on slides. Why is that? Oh, my slides don't work anymore. Thank you, Bill Gates. I appreciate it. I have no idea why it's not working.
You've been hacked!
I've been hacked. You touched it, didn't you, JD?
You should be using Linux.
Yes, I should. You are correct. I should be using Linux. Okay, let's try this. There we go. Chrome was interfering with it, believe it or not. That's pretty cool. Okay, so fire sheet, cookie cadger, editor cap, you heard all that, right? Sidejack. Y'all know what sidejack is, right? Okay. When you log into a web page and it requires authentication so that you can view the contents, HTTP is stateless. That means when you connect to the website, it says password and user ID, you give it to it, it says, yes, you're allowed this data. It gives you a copy of the source code for the page and breaks the connection and forgets who you are. It's stateless. Your browser begins to parse this information and says, oh look, I need this icon. It goes back and says, hey, on this page, I need this icon. It says, I'm sorry, that's a protected page. Your user ID and password, please. How many icons are there on your Facebook page? Could you imagine typing in the user ID and password for everyone? Would that annoy you?
Yes.
Well, back in 1994, the guys who at Netscape came up with this idea of a way of making HTTP, which was stateless, stateful, and actually remember where you were and what you were doing and who you are. And the way they did that was a thing called a cookie. That's a cryptographically signed file. It's got some attributes to it. So when you log in, it creates that, puts that in a database pointing to your account, gives you a copy, your browser saves it. Every time you go to the site, say, I like this page. Whenever you ask for a page, it says, I like this contents, here's my cookie. Now you notice it doesn't ask if it requires authentication. It asks that on every page from then on. It says, I want this page, here's my cookie. If I have the cookie, kind of like if I were to borrow your credit card, I can simply provide it for payment. Well, I can provide the cookie. It's good for authentication. The problem is the logging is encrypted, the contents of the page are not. So as soon as it's done setting up the cookie and logging you in with a secure password over HTTPS, it then reverts to HTTP, hands you the cookie, and gives me a copy to you. I then replay the cookie, and I now control your account. The solution for this is to also encrypt the session. But not only that, there's some other things they have to do as well. I'll show you what those are here in a second. If you don't do those things, then there are ways to get around the fact that the session is encrypted and still get your cookie, which is bad. And by the way, if you want to see that in action, participate in the Capture the Flag, because they have those vulnerabilities in the sessions over there. It's really awesome. Okay, see this multicolored graph here on the bottom? This graph shows how many access points over time have encryption, how many have open. That graph is, if you go to the site, you can get updated information. That graph is having an increase in open Wi-Fi. And the reason is because there's a consortium going around installing open Wi-Fi everywhere, so they can track what's going on. Also, as a customer service, if you're a Comcast customer, they have their Xfinity Wi-Fi project where they go in and turn everybody's access, your router at home into an access point for no extra charge. You get free wireless. Isn't that wonderful? Did they mention there's a second access point built into it for guests? Now, they don't count for your bandwidth, and they're not on your local network unless they exercise the vulnerability that's in the system. But that's beside the point. The point is, everybody gets open Wi-Fi. They're putting it in places you never thought of, like grocery stores, because guess what these guys do if Wi-Fi is turned on? They're beaconing all the time. Even though they're not associated, we can hear that. They can literally track where you go in the store, where you hang out, what display you stood in front of for a long time. They can get that information. They're doing this all over the place. People go, no, I can't possibly do that now. Really, Facebook is even giving away a free Wi-Fi. When does Facebook ever care about your personal privacy? Okay? So the consortium is doing all kinds of stuff. The other thing is we're killing the 4G network. So they want to offload this traffic with public Wi-Fi as part of their service agreement to get $15 all you can eat every month phone. You have one.
Right there.
Yeah. The rule is we will use an open Wi-Fi access point to offload our traffic anytime we can find it. And you can't turn it off. Right? Now the problem is your voice over IP traffic encrypted over Wi-Fi? Maybe. It depends on the vendor. And in more cases than not, it's not. And remember what I said about a public broadcast, anybody can receive it? Yeah, there's automated tools, by the way, that we can throw against this data stream to pull out voice over IP traffic. Or all the pictures you're posting to the secret wall in your Facebook page you don't want anybody but your closest friends to see? Yeah, we're going to see those too. Well, actually, Facebook is now encrypted properly, so they're doing fine and doing it right, by the way. Now, Comcast recently deployed 50,000 of these access points in Houston, and they're doing it across the nation in the hundreds of thousands. You're going to see a massive upsurge in open Wi-Fi.
I saw one in the hotel that was exiting here.
Yeah, yes, I did see one when I was doing the site survey here. I saw one for that. In addition, not only are people like governance interested in this data, so are the criminals. You notice now that there's been a bunch of articles about people bringing up pineapples and hijacking sessions. Okay, my question is, why, when you can just do it passively and I can't tell you you're doing it? Why do I need a Wi-Fi pineapple? I don't know. They need to catch up on the times. We were using these techniques back in the 60s, 70s, and 80s. By the way, they worked very well. We won the Cold War, and we don't speak Russian or we don't. Although I do happen to work with a Russian guy who's my counterpart in the Russian military, which is kind of cool that we can be friends now. Now, there is a basic premise why you should not encrypt your Wi-Fi. You shouldn't do it because of this basic problem. The premise is that WEP stood for Wired Equivalent Privacy. How many of you think the wired network is private? If you do, have you heard of this guy named Snowden? You heard about him? That's all about the fact that they have been capturing all our traffic. Who's they? Let's say every government on the planet. NSA, the BND, the GCHQ, that's the American, NSA is American, GCHQ is the NSA equivalent for England, and BND is the equivalent for Germany. Surprise, as the kid demonstrates here, the wired network is not safe. So what should you do then? You should encrypt your Wi-Fi. Well, wait a minute, I just got done telling you should encrypt your Wi-Fi. Why am I telling you to encrypt your Wi-Fi? Because that's not the reason you're doing it. It's not to protect your data from the NSA. If you want to protect your data from the NSA, you have to use end-to-end encryption for everything. And there is a movement toward doing it. That's the only way to protect your data, period. If you're using a VPN, all you're doing is moving the endpoint to a centrally located point that's easier to monitor than having to monitor the entire network. Sorry for people at home, I just smacked the mic. It was annoying me. So why should you encrypt Wi-Fi when I just said you should encrypt Wi-Fi? Are we in trouble? That is an awesome costume. By the way, that's Russian? Yes?
Soviet, yeah.
Soviet, yeah. This guy just walked in a Soviet Army officer's outfit. It's really awesome for those at home who don't see it. So, it's Halloween for, if you didn't know, this is a Halloween PhreakNIC. The reason you encrypt Wi-Fi is for a reason you never expect. You need to protect your home network because the police department can't determine whether you're the good guy or the bad guy if you're running an open access point. If you're a Starbucks, it's kind of obvious you're a business. But you can't go do some kind of nefarious things on the internet from your open home and run an open Wi-Fi access point and expect them to say, oh, but somebody else could have done it. That's like saying your dog ate your homework. They just don't buy it. In fact, how bad don't they buy it? Well, first off, did you realize that they did a survey, and 32% of people that they surveyed said, oh, if I see an open Wi-Fi, I just use it. There have been multiple cases now about people using open Wi-Fi to do criminal acts. One of the more interesting ones was the guy who had a SWAT team, fully armed with flashbang grenades, burst into his house, take him and everybody else in the house down, and accuse him of child pornography. They eventually discovered it was somebody else in the neighborhood using his open Wi-Fi access point. This is only one of multiple cases I've been tracking where this has happened. You are blamed for the traffic coming out of there until they can prove otherwise. So if you want to protect yourself from people actually attacking the machines on your network, and protect people from using your bandwidth and you getting the contents of that bandwidth and you getting blamed for it, I'd highly recommend you encrypt your Wi-Fi. But if you're doing it to protect your traffic from being snooped, it's not helping. You need to use end-to-end encryption. HTTPS is your friend. Don't use browser autocomplete, by the way. The problem with browser autocomplete is, you know what I mean by that? If you type in Facebook and hit enter, it seems to go to facebook.com. And the way it does that is to help you out. If you type in Facebook, it says, that's not a fully qualified domain. Let me stick .com in the end and see what happens. Oh, that resolved. Okay, let's try the HTTP protocol. Oh, it responded. Okay, fine, display that page. Guess what happened? It's not as true anymore, but guess what used to happen if you typed in White House?
WhiteHouse.com.
WhiteHouse.com was one of the most notorious porn sites on the internet. And you're at work and you meant to go see the latest whatever that they announced on the White House webpage, and the next thing you know, you're looking at this 30-inch display of porn in your office and he's turning and looking at you. Okay? Well, that has been taken down. WhiteHouse.com does redirect you to WhiteHouse.gov now, but that's not true of many sites. Or Disney, if you spell it wrong, takes you also to a porn site. If you use fully qualified URLs, by the way, how many protocols, the HTTP part is the protocol that your browser will handle. How many protocols does a browser handle on Windows out of the box?
5, 6, 7.
You're off by an order of 10. 70 out of the box. It's going to guess. If you want it to guess wrong, don't tell it. I'd highly recommend you tell it. Or better yet, since we're fumble-fingered, I got big fat fingers for those who can't see, you need to use a bookmark. Solves the problem. And use HTTPS. Use full end-to-end encryption. You can get add-ons for Firefox and Chrome that help with this, like HTTPS Everywhere, that forces them to do it. Also, you can use these tools to force the secure cookie attribute and the HTTP only attribute. Unfortunately, there's no tool for that one, which is also important, but we're going to talk about those in a second. Firebug is a tool that you get for Firesheet that allows you to view all the information, including all the cookie information and how they're doing their cookies. What's important is this. There's a flag in the cookie called the secure cookie flag. Why that's important is when I send you the cookie and you got it via a secure channel, if I can get you to talk to Facebook, like let's say you just type Facebook and hit enter, because you inadvertently closed the tab, it's going to go to facebook.com first, hand over the cookie in clear text, then redirect you to HTTPS, and I own your site. Congratulations. The solution for that is to turn on the secure cookie flag. When that happens, the browser will refuse to divulge a cookie unless it's over HTTPS. It won't fall for that trick. Facebook sets that correctly. So does Twitter, so does Google. Another one is HTTP only. It's possible to have another process in your browser, like JavaScript, ask for the cookie, and your browser will say, sure, here. So I can use Java injection on a frame to read your cookies, okay? The problem with that is if you turn, or the solution there is if you turn on HTTP only, the browser will not divulge it except over a connection. And if the secure cookie flag is on, only over a secure connection. You also need to set the domain path, which determines what site that cookie is valid for. That needs to be set correctly. and the max age. Like if you have a cookie that you authenticated back in 1982 and it's still a valid cookie, that's not good. Okay? They need to set all those, and they need to set them on the server side. Are they doing that correctly? And the answer is no, not really. That's why they have the OWASP Top 10, which is what we'll be talking about during the Capture the Flag event. Using a VPN will protect you for the wireless intercept, but it won't do anything for protecting your data ultimately from intercept. You need end-to-end encryption. If you want more information, go to my website. You can go to my Georgia Tech website, or you can go to NarkNet.com, and there's... Oh, I need to redo that. That copy URL has been changed. If you just go to NarkNet.com, there's an FAQ with all kinds of data. I'll be happy to talk to you all next door if you want. We're going to be running a live demo the rest of the weekend once I get it set up here, and we're going to actually be intercepting and playing the data. We're not going to actually click on anything because that's a crime, right? Repeat after me. If you click on it, it's a crime. Very good class.
In Georgia.
Actually, in quite a number of states, and some of them are far more egregious than Georgia. Some of them are now saying, if you intercept the data, it's a crime, and they're doing it as state law. They're starting to enact that. I'm just starting to follow that, so I'm not up on all who does what where.
Well, if you borrow your significant other's Netflix password in Tennessee, it's a felony. So I would suspect that we can't get away with it here either.
Oh, and by the way, thank you for reading that. She said if you use your significant other's Netflix password without permission, that's a crime in Tennessee. Okay? So that would make clicking on one of these things a crime here. Now, just so you know, one of the most egregious violators of pretty much everything regarding security of your traffic is Netflix. Just so you know. So, any questions? Oh, do I have your credentials? Yes, I already have your credentials. If you've seen the sticker on my laptop, it says my other laptop is your laptop. But just so you know, yes. No, I made that question. Nobody asked that question for everybody playing the game. Any questions? Yes.
So we should record all the data and then go to China and play it back.
Actually, he said, should we record all the data, go to China and play it back? No, because the Chinese already have the traffic, there's no need. Yes?
Can you recommend that you go to hardware with like 11 concurrent or 14 concurrent antennas?
Actually, no, he asked if I can recommend any equipment with 14. The reason he asked for 14 or 11 antennas is because in the United States there's 11 channels. However, overseas there's actually 14, up to 14. Japan, I think, uses channel 14, yes?
Japan uses 14. There are a few other places that do as well.
Yeah, and by the way,
But
let's
don't
see.
use 13.
Yeah, it's not legal to use
14 in the U.S.
yeah, was it 12, 13, 14
There
in
is
the U.S.? There is no 12.
There is no 12 or 13.
They're not legally used in the U.S. technically, but I've never seen the FCC chase somebody down and do it. Although I do know somebody who ran a clandestine radio station back in the day, and they did track him down and bust him. So, say again?
If you're over 1 watt, which is whatever that ham radio limit is, if you're on, or if you're off the wrong frequency.
Yeah, he was actually transmitting on the FM band, so they did.
What I'm asking is, if you want to record all the channels, concurrently, is there any better solution than a big nested USB dongles on your desktop?
Currently, not that I'm aware of. Yes. Oh, you heard that at home. Yeah, right. No, currently no. I don't know of one. And there's also the issue of not any just any USB adapter will even work because of the multi-string problem. If you want to get into the technical stuff, we can go way nerdy. I'm really into this stuff. This gets me really excited. Just ask Loretta. I would literally vibrate. So, any other questions? Yeah.
Are you going to be posting the slides somewhere online that I can review?
I didn't catch that, right?
Publish the slides online?
They are online. If you go to those links, they are online. Yes. In fact, the link to these two sites is on the PhreakNIC site. So if you go there, it links back to these sites. And also my email's there, so feel free. If you have questions, you can always email me and ask me questions. Yeah, you have a question?
Oh, no, I was just doing thumbs up because you guys are stuck.
Yes. Definitely have a link to PhreakNIC. Johnny S. and I go back a long ways. By the way, you know the cattle prod? Yeah, I'm the one who fixed that. And
That was me.
That was me. I admit it was me. I'm sorry. Although I have enjoyed the festivities ever since because it's thrown around and shocked a lot of people. Any other questions? No? Okay, well, thank you for coming. And now I want you to go home and start practicing safe Wi-Fi, okay? And please do not let me see you in the paper with handcuffs on for having sniffed Wi-Fi and done evil things with it. Thank you. Have a good one.